Howdy everybody, thanks for watching today. We are finishing up the section 4.5 notes about using the quadratic formula. I believe yesterday we made it to number 7. You congratulated yourself on learning all 5 methods for solving quadratic equations. So number 8 is where we'll start out today. Now that you have so many methods at your disposal for solving quadratic equations, you kind of need a game plan when a problem tells you to solve the equation by any method, which is what our assignment does today. Each method has kind of its advantages and disadvantages. We talked about these the other day on one of our starters, but here is what the book has. It's got a nice little chart here, each method and then the advantages and disadvantages. I know when I do a problem that says solve by any method, I have kind of a game plan that works for me. So my method is I look and see if the equation will factor. If it looks really hard to factor or it won't factor, then I skip down straight to the quadratic formula. Now that changes a little bit. If I can use Desmos, maybe graphing would be in my game plan somewhere along the way, because that's pretty easy if I can use Desmos. But if I can't use Desmos, I don't really graph anything. Some of you might like completing the square. It's up to you. It's your game plan. So what we did in class actually is we took a couple minutes and I actually had them write down all 3 of these examples. So if you wouldn't mind, here's example 1, x squared minus 10x equals 1. Example 2, 2x squared minus 13x minus 24 equals 0. And example 3, x squared plus 8x plus 12 equals 0. So what we did in class is I had them work for like 5 or 6 minutes, and they tried to solve all 3 of those using their game plan, whatever method you want. So why don't you pause the video, try and solve all 3 of those by any method, your choice. Okay, hopefully you paused the video and did that. Now, let's see how you did. Most people on example 1, I actually had them raise their hand and say which method they used. They found that factoring didn't work on example 1. So most of the people did completing the square or quadratic formula. Probably more quadratic formulas than anything. What you have to do first is minus that 1 over, so it equals 0. And then you can start setting up the quadratic formula. So it'll be negative b, which would be 10, plus or minus the square root of b squared, so negative 10 squared, minus 4 times the a number, which is a 1, times the c number, which is a negative 1, all over 2 times the a number, which is 1. In my calculator, when I did that big square root part, I got about 10.2 over 2. My 2 answers then ended up being x equals 10.1 and x equals negative 0.1. So hopefully that worked out for you and you got those same answers no matter which method you used. Example 2. This was kind of split down the middle. About half the kids in class solved it by factoring. The other half of the kids in class said, well, factoring looks a little tough, so they just went straight for the quadratic formula. I think on the board in class I showed the factoring method. Going for the x method. What multiplies to be negative 48 and adds to be negative 13? I think it's negative 16 and positive 3. Divide both of those by 2. So negative 8. We'll have x minus 8 and 2x plus 3 as our factors. That all equals 0. Set each one equal to 0 and then solve it. Pretty confident that you can do all that. So I will just write the final answers. X would equal 8 and x would equal negative 3 halves. So hopefully you got those answers no matter which method you chose. And then example 3, this one was probably actually the easiest out of all of them. I think a lot of kids said they factored and some said they did the quadratic formula. There were a couple maybe that completed the square. Save us a couple minutes here. In the end, x should equal negative 6 and negative 2. So hopefully you got those two answers no matter which method you used. You could message me if something didn't quite work out right on those and I'd go through it with you step by step. So hopefully you've got a game plan. You know which methods you like, which methods work for you, and you can use them to solve these quadratic equations. Last thing, couple story problems. Here's the first one. It's also on your guided notes. This one is about northern Rocky Mountain wolves. They must have kind of been an endangered species or something, but the number y of northern Rocky Mountain wolf breeding pairs X years since 1990 can be modeled by the function, that function. When were there about 77 breeding pairs of wolves? So what we want to do is we're going to use this 77. That's the number of breeding pairs, and y is where we plug that in. So it'll be 77 equals that whole equation. Factoring's definitely out on this because of the decimals. I think pretty much everyone in class was like, oh, quadratic formula for this one. So to use the quadratic formula, we'll subtract this 77, get everything on the right side. So we have 0 equals 0.20, whoops, forgot my x right there, x squared plus 1.8x minus 80. Now we can start in with the quadratic formula. Squared. I think it takes just as long to write it as it does to actually solve it. So let's see, negative 4 times a times the c number all over 2 times a. When I plugged all the square root part into the calculator, I got about 8.2 when I did that, over 0.4 on the bottom. So my two answers were x equals 16 and x equals negative 25. And the negative 25 we can cancel out right away because this is a time problem. We can't go backwards 25 years. No time machines have been invented yet. So we have to just go with a positive answer. Whenever something's about time, we do that. And I think they actually said X is the number of years since 1990. So 1990, and then we go 16 years after that. So 2006 is when there would have been 77 breeding pairs of northern Rocky Mountain wolves. The second story problem, occasionally you'll see like a geometry problem thrown your way. It says solve for x and find the dimensions of the rectangle. Well, a rectangle is just whatever its base is, which they gave us an expression for its base, and whatever the height is. You multiply those together. Base times height equals the area, which they also told us, that's 91. Now, a couple people were like, oh, that's really easy. We should just say 2x plus 3 equals 0, and x plus 2 equals 0. It doesn't work, though, here. Your original equation has to equal 0. That rule is called the zero product property. So if your original equation doesn't equal 0, then you can't use the zero product property yet. So I made the kids in class think for a few minutes, and eventually somebody kind of got this idea going that maybe we should multiply these together, do kind of our FOIL method, and then we can minus this 91 over to the left side, and then it will equal 0. So doing a little foiling here, first outside would be 4x, get squared there, inside would be 3x, so the O and the I part would give me 7x plus 6 equals 91. Now we'll subtract that 91 over to the left side. So 2x squared plus 7x minus 85 is what that would be, equals 0. And now you can use whatever method you would like. It actually ends up factoring. I think a lot of kids in class chose the quadratic formula though. Either way, save a little time. Once you do your method, you should be getting x equals negative 17 over 2 or x equals 5. Those are your two answers that you get. Because this is geometry, we can't have any negative side lengths of this rectangle. That'd be a really weird rectangle if it had like a base of negative 3 feet. So we only keep the positive once again. So x equals 5. That would mean this base, if I plug a 5 in for x, would be 13 feet. And the height of the thing would be 7 feet. Make sure your method worked out and you can actually get those two answers. Message me once again if it's not working for you, and I'll kind of take you through the rest of it step by step. Thanks as always for watching. That is the end of 4.5. You guys are all fantastic, and I hope you're back in class soon.